steel pipe manufacturing process heavy trucks rumble through the gates. As morning mist clings to the cold air, forklifts move quickly across the yard, lifting heavy steel billets from stacks lined in rows. The metallic thud of steel on steel echoes across the plant as a crane lowers its hooks onto a billet and lifts it toward the heart of the operation. The billet glides down a loading track and vanishes into the mouth of the induction furnace. A sudden orange glow reflects off the surrounding walls. Flames lick the edge of the metal as temperature rises above 1200 degrees Celsius. Operators watch closely from behind glass shields, checking temperature readouts and flow rate control. Panels blink with green lights as the billet softens under the intense heat inside the furnace. The billet transforms, no longer cold and gray. It glows a hot, pulsing orange, almost alive. Rollers extend and transfer the billet toward the piercing station without pause. It enters a set of counter-rotating rollers in the center. A rotating cone-shaped plug drives straight through the billet's core. Steel stretches, forming a hollow center as the shell begins to resemble a pipe. The newly formed hollow shell moves swiftly along to the elongation mill. A series of rollers clamp down with precision, stretching the metal. Refining the thickness, length, and roundness. The red-hot pipe is in motion, constantly rotating, growing longer and more uniform with every second. Sparks spit into the air. The rhythm of machinery roars overhead like thunder. Technicians monitor from control booths, communicating over headsets, checking digital dials, making microscopic adjustments, one stretch to the desired length and diameter. The pipe passes through cooling rollers. Water sprays down from above, coating the pipe in fine mist. Steam explodes upward in clouds. The orange glow fades slowly, replaced by silver-gray steel. As it cools, sensors mounted along the line begin taking measurements. Laser-guided devices scan the pipe. Inner and outer diameters are recorded. Wall thickness is logged in real time. Tolerance readings flash on overhead monitors. A robotic arm sprays a color mark on one pipe, signaling slight deviation. That pipe will follow a separate track for further inspection. Those that pass initial inspection continue toward the sizing mill. More rollers compress the pipe, fine-tuning every dimension to exact specifications. No part is left untouched. Everything is about consistency, about perfection. Then comes a quieter section, but just for a moment, the pipe now reaches non-destructive testing. It's sent through magnetic and ultrasonic sensors. These advanced machines peer beneath the surface, detecting internal cracks or faults invisible to the eye on a nearby screen. A live waveform appears. Any abnormality triggers a flag. But today's run is clean. The finish link is still. Too long for transport or use, an operator initiates the cutting process. A high-speed circular saw whirs to life. Sparks shoot across the room as steel is sliced into 6, 9, or 12-meter sections. Each cut is precise, clean, timed perfectly, freshly. Cut each pipe section is transferred to the chamfering station. mechanized tools rotate around the pipe's edge, shaving it clean, creating a smooth, beveled edge. A separate tool deburs the interior and exterior. Ensuring no rough edges remain, the next stage is pressure testing. Each pipe is sealed at both ends and filled with water. Pressure builds inside rapidly. Engineers watch the PSI reading rise. The pipe holds, no drops, no leaks. Another passes, one fails. A small stream of water seeps from a tiny crack. Red paint marks it for recycling. The good ones continue down the line. Coating begins. Pipes roll through a sealed spray chamber. Robotic arms douse the steel in a layer of anti-corrosion material. Usually zinc rich, no spot is missed. The pipes spin slowly as mist wraps around them. The protective coating cleans evenly. Inside the drying tunnel, fans blow warm air over the surface. Within seconds, the pipes emerge fully dried, glistening faintly under overhead lights. Next, an inkjet system stamps each one. Diameter, wall thickness, heat number, lot code. Date of manufacture, every number matters. Every detail is traceable docked at the bundling station. Robotic claws align the pipes with mechanical precision. 10 to 12 pieces are stacked in formation. Steel bands cinch around them, holding tight. Labels are printed and affixed. The operator checks against the order sheet. All clear, the loading dock comes into view. A forklift rolls up, lowers its prongs under the bundled pipes, and lifts with caution. The load is placed gently onto a flatbed trailer. of the plant. Another load of raw billets arrives at the gate. The cycle never stops inside. The furnace fires again. A new billet is already halfway in. In another hour, it will become part of a pipe destined for buildings, bridges, rigs, or refineries. Dot above it all, the factory hums. Machinery doesn't sleep. Operators rotate shifts. Welding sparks flicker in a corner. Someone inspects another. Length of pipe under white light. The radio plays faintly, drowned out by the echo of rolling steel. Night falls outside, but within these walls, the heat, the noise, the precision, they continue. A line of glowing billets waits near the furnace. Their transformation is just about to begin.